All right, this morning I sent you an email and it's got some PDFs in it. And what I'm going to do is we're going to go over Chapter 9, but before we do, I'm going to go over one of these PDFs because I think it actually does a better job of starting to introduce object-oriented programming to you than our book does. All right, and that's the reason for going over it. So there are 4 PDFs in here. They're called C# collections.pdf, C# properties definition.pdf, C# object-oriented programming 1.pdf, and C# object-oriented programming 2.pdf. I'd like you to go to the third one, that's C# object-oriented programming 1.pdf. All right. Otherwise, just look up here, whatever you want to do. But this is what I'm going to start going over right now. All right. And in many ways, this is different than anything we've done all semester. But in many ways, it's not, because we have been using object-oriented principles all semester. All right. You probably didn't think about them that way. In other words, you probably didn't think, oh, I just put a button on the screen. That's a button object. So that's an instance of a button class. But that's, in essence, that's what you were doing. All right. So what they have in here is they have some code examples, and there's a lot of definitions in here also. So you'll see it here. Then we'll go back and we'll go over Chapter 9 as well. All right. So they mention here, it says there are 3 widely used programming paradigms: procedural programming, functional programming, and object-oriented programming. And C# supports both procedural and object-oriented programming. Virtually everything we've been doing thus far has been procedural programming. All right. In other words, when you think about it, whether it was a GUI application or a non-GUI application, okay, we might have had a main if it was a console app, but then we added more methods or functions as we needed them. We did the same thing for our GUIs. All right, that's not going to change, but on an as-needed basis, we'll be adding more classes too. All right, and again, don't worry about what class means. We're going to get into all of it. But one thing to keep in mind, you don't have to write this down, but you have to kind of remember it. When you create a class, all right, even if it's in a GUI program, classes have no GUI components in them. Did you all hear that? Classes are code. All right. So the author here defines object-oriented programming, or OOP, as it's known, as a paradigm that uses objects and their interactions to design applications. What does that mean? Well, if you look up on the screen here, these are what are considered some of the pillars, some of the foundations of object-oriented programming. And they give you 4 terms here. Again, you're going to hear these for the next few weeks. Those terms are abstraction, polymorphism, encapsulation, and inheritance. And it says abstraction is simplifying complex reality by modeling classes appropriate to the problem. What does that mean? Well, in much the same way, and I may have even given an example like this before, I don't know, but you typically, if you bought a lot and we're going to put a house on it, you typically wouldn't have somebody come over and, with a big truck or a big excavating unit and dig a hole and start building the house. You'd probably contact a builder, an architect, or someone else and have them create a model so they would show you what the house would look like. Well, that's what object-oriented programming is. It's a big modeling type of thing. All right. If you remember, before they up and left, the city of St. Louis was going to build a new football stadium for the Rams. All right. And maybe you saw it on TV. They had pictures of it, but they had a model of it that somebody created. They weren't going to just go out there and start creating it. They were going to model it first because it's much easier to pick apart the model and make sure that's what you want to do before you go out and do it. All right, and that's kind of what abstraction is. All right. The next word that's in there is polymorphism. It's a Greek term and it means many forms. Now, I think I've put something like I'm about to put on the board up here before, but again, you're going to see this. We could, for example, create a class that's called animal. And under animal, we could create 3 other classes: dog, cat, and bird. And if we came in here and under animal, we defined a method or function called speak, well, speak would be done differently by a bird as opposed to a cat, as opposed to a dog. They'd all speak, but what they'd say would be different. All right? So in other words, when you can have different things react differently to the same input, so to speak, that's what polymorphism is. All right? The third one is encapsulation. And with encapsulation, it's when you hide details. It's what's known as a black box mentality. I have shown you this before, that if I come out here, go to calculator, key in a number, and hit the square root key, I have absolutely no idea how it did that. All right? That is the implementation for how that was done is hidden from me. When you hide the implementation for how something is done, that's what's known as encapsulation. And again, I may have said this to you before, we pretty much live our lives in an encapsulated way. When you think about what you do all day long, there's a lot of things you do, but you never think about how you do them. You know, how your car moves. You know, even exactly what happens, you know, when you open the door here or whatever it is. When you turn the computer off. That type of an idea. And the last thing is inheritance. And again, I believe we've discussed a little bit of this already, but when you have inheritance, you can form new things from existing things, much like genetic inheritance. All right? Okay. So, when you work with object-oriented programming, okay, notice it's called object-oriented, but the first thing that you do is you create a class. A class is one of these blueprints. So again, if I created a class called person, okay, I could give them both attributes, so things that they have, a height, a weight, a gender, an eye color, a hair color, and I could give them behaviors, eat, drink, sleep, etc. All right? And then every time I created a person object, okay, that would be an instance of the person class. So an object is an instance of a class. In fact, the act of creating an object from a class is called instancing or instantiation. All right. So here's an example. I'm not saying it's a great one, but it's an example. And if you look right here, they're creating a brand new class. It's probably the dumbest class you could create because there's nothing in it. It's absolutely empty. But it's the word class followed by the name of the class and then in parentheses what the class holds. All right? You may or may not have noticed this, but everything we've been doing thus far, even this, you know, if we look, for example, in a, if we look at what we've been doing so far for our console programs, we've always had this class program. And that's that program.cs file. And the only thing that it's held has been, well, typically, by default, all it holds is main. And main is called a method. Because when you create something like this inside of a class, it's called a method. All right? If you create something like this outside of a class, it's called a function. But if it's within a class like this, it's a method. All right, so literally, there are 2 classes that you see on the screen right here. Being and program. And you'll notice that what does program do? It creates a brand new class or a brand new object, a brand new instance of a being class called B. And then it prints it out. Well, since it's empty, there's really nothing to print out. But that what they have there is totally legal code. That's the key thing. It's all legal to do that. So what I liked about this, and I read a bunch of these over the weekend, is this one not only shows you something like that, but then explains it in, I think, better detail than our textbook does. All right? So that's creating the class. That's creating an object based off of the class. Again, there's no body in here. It's just curly braces. All right? So you'll notice that when we run it, it says being.being. What does that mean? It means basically that's the whole thing. That's all that's in there. Okay? It says we get the object class name. Not very much. Well, that's not typically the way you're going to create something. All right? So if you look here, it says object attributes are the data that are bundled inside. So a class contains what are called data or attributes and methods, which are behaviors that act upon that data. All right? So if we look in here, we've got a class person. Now it's a little different. It's called person, and the person has a name. All right? They're going into this very slowly, and let me just tell you right now, this is a stupid example. And the reason it's a stupid example is virtually 100% of the time, when you create this, you never make your data public. Never. There should never, if you're writing this in the correct way, your data should never be public. So, well, then why the hell did they do that? To show you that you can. And what you're going to see when we go over it here and a little bit in Chapter 9 is there's public, there's private, there's protected, and there's even something called internal. All right? Yes?
What's the difference between classes and different methods?
It's everything that we're doing here we could do without using classes. Okay? The way we've been doing it so far. The problem is, when you do that, it's much harder to reuse the code than it is by putting it into a class. So, well, I'll give you an example. Let's suppose that you graduated from here, and you got it. You went out and you started your own contracting firm, and you got a job. Enterprise talked to you, and they said, "Hey, we want to totally redo our reservation system for our cars." So you agree to do that for them. All right. Now you're just about done, and you get contracted by Holiday Inn, and they say, "You know what? We've got a reservation system too. It's not exactly the same, but we reserve rooms as opposed to cars." Now you can take that system and make minor modifications and use it again. But when you do it with a non-object-oriented method, typically you have to almost start from scratch. So that's, I don't know if that answers the question, but that's typically why you use it. Most managers, when they hear code reuse, they hear the ka-ching, ka-ching in their heads because it says, oh, that's going to save us money. And I mean, bottom line, with many managers, that's part of their job, right, is to do that. And that's one of the things that you get afforded with object-oriented programming. All right, since this is public, since this piece of data here is public, like I said, it really shouldn't be, but they're trying to show you something here. Since this piece of data is public in class person, notice I can change it in class program. Does everybody see what I'm talking about? You defined it in class person. You defined an attribute called name. Don't worry if it's a first name, a last name, both. That doesn't matter. All right? But since you made it public, I can modify it right here. That's not typically what you want to do. All right? In fact, in a nutshell, what object-oriented programming usually is you define private data, and then under your private data, you define public methods. So the only way that you can modify your private data is through your public methods. And if you say, I don't get it, that's what the rest of this is about. All right? And I've been thinking about this. There's actually a good chance that rather than going over 9, 10, and 11, we might go over 9, then have a test. Then go over 10 and have a test. Then go over 11 and have a test. That's how complex this stuff is. And I don't want, you're only going to probably have one problem. But I don't want it where, you know, it's like, you gave us way too much. I can't do this in 4 hours. All right. So as the author says here, in the above code, we've got person with one field that's public. Notice the public keyword specifies that it's accessible anywhere. What that means in this case is one class can manipulate the data from another class. You should strive to never allow that to happen. I mean, you know, if you said, well, why? Well, first of all, it's bad policy. Second of all, it can lead to what are called side effects, where you've got some class that should never have access to something now can have access to it. All right, it would be more or less along the lines of, you know, and again, maybe I've given this example before. I can go out to Rankin's intranet, and I can find out all sorts of information about me. When I bought my house, all right, I went out there and I changed my address. I could go in there and I could see my earnings statement since I've been here. I could look at my W-2s. I couldn't go in and look at Mr. Corrigan's W-2s. My data was private. It was public to me, but it was private to the rest of the world, except the people who work in payroll and the like. And the same with other people who work here. All right? The other thing to realize is when you do this, notice how they came in here and they made 2 persons or 2 people. One that was called P1, one that was called P2. And each one of them has their own name. You know, it's a big deal. They should have, they should have their own name. But what that is, when you say this right here and this right here, you're manipulating that variable right there. All right. So again, if I'd have come in here and said person, and I'd have said public string first name, public string last name, etc., I could change all of them in here. All right. That's the thing to realize. All right. Methods, as it says, methods are functions defined, I should say, inside the body of a class. Notice methods are essential to encapsulation. And they give an example here, which is actually a really good example. After we get back from the break, we're going to talk databases. And eventually we want to be able to combine using a database with C#. All right? So in our C# code, we're going to have to call a method like a connect method so we can connect to a database so that our program knows about an associated database. I have no flippin' clue how that works, and I don't need to care. All I need to care about is that I call the connect method correctly and that it connects to the database. The rest of it is encapsulated or hidden from me, and that's what they're talking about here. So I wish they'd have kept with the person thing. They didn't, but if you would please look up on the screen here. Notice that now the data that's in here, notice that the data is private. And also notice that the methods, so the data is radius, the methods are set radius and area. They're both public. So the only way that this class right here, right now, can actually manipulate this data, this private data, is through these public methods. All right? So the whole idea is you're trying to get some semblance of control over this. That's what we're trying to do. All right? And it's not even called control, but it's called data access. So the only way to access this private data is through these public methods. That, by and large, that's what object-oriented programming is all about. You make it private in here so that only these methods can manipulate it directly. It can't directly be manipulated in here. All right. Now, a couple things. First of all, is it possible that you can create data and make it public. Yeah, that's the first one we saw. Just because you can do something doesn't mean you should do it.
How do you decide what to make?
You virtually never make any of your data public. That's how you decide. All right? And we're going to get down to it when we talk about inheritance. That's a talk for a little later on. All right? But you also can have methods like this that are private. All right? So let's say that in order for this area to do its thing, it had to call another routine. Do you all understand what I'm saying? In order for that code that's in blue to work, it had to call another routine. I wouldn't necessarily have to make that routine public. I'd only have to make this one public. And again, if you say I don't get it, I've given this kind of example before, maybe not here, but probably in the class last semester. It's kind of like, let's pretend for a second here that Chase owes Chris a favor. And Chris says, Chase, go out and get me a Coke. All right? And then we're even. Okay? And so, Chase is like, yeah, okay, I'll do it. But then he thinks, oh, James owes me a favor. So he tells James to go get the Coke, bring it back to him, and he brings it to Chris. Does Chris really care that Chase isn't the one who got the Coke? Probably not. But that would be like, typically it's called a utility method. When you've got a public method that calls a private one to do some work. Now, do you have to do that? No. It's totally possible that you can write a really, really well-written C# object-oriented programming application that has only private data and public methods. But I'm just telling you that it is possible to stretch that and do other things. That's all. So when you look at this, what do we have? Well, we've got two classes. One called circle, one called program. But notice in here now, okay, you may or may not get it yet, but I want you to understand this is creating a new instance of a circle class right there. Okay? So it's going to call something that we haven't even touched on yet, but we will in a few minutes. That's called a constructor. So that will call the circle's constructor. There isn't one, so it doesn't do anything. But it makes a new object called C. But notice I say here C.setRadius 5. If I tried to change this, if I tried to say right here, radius equal 5, I'd get an error message. And the reason I get an error message if I tried to do that, all right, if I said like C.radius equal 5, I'd get an error message because I'm in one class trying to call something in another class that's been deemed private. All right? I will tell you that it probably is, like I said, I'm going over this because I think there's a few places in the book at least where the author could have done a better description and explanation of what she does. But I don't think you're going to totally get this from listening to me if you don't read the book. And maybe even take another look at this. So the author explains that, the private int radius, and it's basically what I just told you. So the author says that the way that we protect our private data is through this or these public methods. All right, so again, in a nutshell, what object-oriented programming is, in a nutshell, is using public methods to manipulate private data. That's what it is. Now, speaking about this, you'll notice I'm on the bottom here of page 6. They talk about access modifiers. And then they mention that C# supports 4 access modifiers. Public, which we already looked at. Protected, which we're going to look at in just a minute. Private, which we already looked at. And internal. If you don't specify any of these, so if I don't say public and I don't say protected and I don't say private, normally it automatically defaults to internal. That's considered a bad programming practice. All right? That doesn't mean people don't do it. If you went out there and you looked, if you went to work for a company, I mean, I found this out when I went to work and as a professional programmer, there's a lot more bad code out there than there is good code. Just because people should do things one way doesn't mean they do them that way. You know, I have mentioned to you that in an ideal world, you modularize your program. And in an ideal world, each module, you should be able to see the whole module on a screen. All right? But I've worked for places where literally one module is 1,000 lines long. That's not a well-written module. But it started off small, and people just kept building on it, and building on it, and building on it. And rather than creating a new module, they just kept building on the existing one. All right? So, as it says, public members can be accessed from anywhere. I've given you that example before, that it's like a public figure who technically she or he should be accessible to everyone. All right? Private is just the reverse. Okay? So private are limited to wherever they're defined. That's why when I had the class and we defined that private radius, it was only directly modifiable in the class in which it was defined. All right? Later on, either this week or next week, we're going to talk about inheritance. And what protected means is that if I define something as protected, it's available to me and to any of my children and to any of their children and to any of their children, etc. All right? And again, if that doesn't make sense, it will make more sense, I think, when you see it in action. Finally, there's internal, which says that it may be accessed from within the same exe file or the same dynamic link library or DLL file. All right? You typically don't use that one. Access modifiers they mention here protect data against accidental modifications, also known as side effects. Sometimes you want a side effect to happen. If I'm told, so if Mr. Corrigan talks to me at the end of the year and he says, hey, I got good news. You're getting a $5,000 a year raise. All right? Well, after I woke up, after I fainted. But that would be, with that kind of thing, I should have even said that now. I totally lost my what I was going to say. But with a side effect, okay, I would want the people in payroll to upgrade what I'm making. That would make sense, right? So if I'm making $50,000, I'd want them to update it to $55,000 because I just got a $5,000 raise. But that doesn't mean that I want Mr. Knott to be able to go look at my stuff and say, hey, Jeff just got a $5,000 raise. Why was mine only $2,000? It's not how things work. So with a side effect, sometimes when you have a side effect, you want those things to happen. Sometimes you don't want those things to happen. What happens if you make everything public? What that means is any routine in any class can change. If you made your data public, that would mean that any routine in any class could change your data. That's about as bad as it gets. All right? All right, as it says, they protect data against these side effects. They make programs more robust. Now, the author is still trying to show you a few things here. So if you look on the screen, notice they've got public string name, private int age. So now they're mixing, which is totally legal to do. But again, that means that name, since it's public, can be set in another program. But age cannot. All right? So the author, basically, they're moving towards where they want to go, but they're showing you can still, there are rules that should be followed, but you can break them. It's your code. All right? But if you break the rules, you're going to make it easier for somebody else to screw up your code. Again, if a member field is private, the only way to access it is via its methods. If we want to modify an attribute outside of the class, the method must be declared public. All right? What I just mentioned. So if you notice the next example here, and I'm on page 9, now they've got 3 pieces of data. And what that means is name is available to anybody, ID is available to this class and any of its child classes and any of its child classes, etc. I mean, imagine it's this way. I've got something, and I make it protected. That means that my kids can do whatever they want with it, my grandkids can, my great-grandkids can, etc., etc. All right? And then we've got something that's private. Sometimes you do make your data protected. There should never be a reason that you make your data public. All right? In fact, there are people who are called OOP, that's object-oriented programming. They're OOP purists who say you should never make your data anything but private. I mean, I've gone to conferences where I've listened to people argue about this stuff. I mean, it's their life. And I've seen people literally almost come to blows over this. When somebody says, yeah, there's sometimes there's good reasons for making, because I was at one once when a person basically said that. The person up there with him basically turned to him and said, you're an idiot. All right? It just depends. It's always dependent upon what it is you're trying to do. But in an ideal world, you should strive to make your data always private, your methods public. Now, you're going to see this. Notice we've got this, class base. And then you see here it says class derived, and it says base. What that means in a nutshell is derived is a child of base. It's a child class. All right? And if you don't get that, you won't until we look at it in more depth and breadth of coverage. All right? And I will tell you, you might look at this, you might walk out of here today and go, this is just a bunch of crap. I don't know why we have to learn it. I don't know who'd want to give. This is the way things are going. This is what they expect you to know and be able to do as a C# programmer. You say, well, okay, then I'm not going to be a C# programmer. This is also the same way they do it in Java. And to be honest with you, if you're going to be a JavaScript programmer and you're going to do anything that interacts with the server, this is the way they do it in JavaScript. The syntax is different between the different languages, but the way it's done, all right, it's all object-oriented. So you look in here, and it says var derived equal new derived. Then it says derived.info. Okay, well, who cares? All right. Well, what happens here? Well, it says var derived equal derived. So it's going to call this, and it's going to write this stuff out. This is derived class. Members inherited. All right. And then it's going to say this dot name. Boom. And it's going to say base. This dot ID. And it's going to say 5323. This dot is defined. And I don't know if it's going to say true or it's not going to say anything. All right. But the point is, what happens is this class right here, this class, I should say right there, automatically gets everything that was defined in its parent. All right? It automatically gets it. But if it wants to change it, it has to use methods that are defined in the parent or that are public methods. So you can only change private data, typically using public methods. All right. So what happens when you create an object? When you create an object, what happens is a special method called a constructor is automatically called. So if you look up on the screen here, you may or may not notice it until you take a good look at it. The name of this class is being. then notice we have two different methods that are both called being. If you remember in one of the last chapters we went over, we talked about overloaded methods. This is an overloaded constructor. Here's a constructor with nothing passed in. Here's a constructor with a string passed in. All a constructor is it's a special method that's called whenever you create an object. I can't put it any simpler than that. Okay? And you'll notice in this case, all it says is being is created. You pass nothing in, and here you have to pass something in. So maybe, notice we call new being right here. So all that's going to happen is it's going to write being is created. Then we call it again, and we've got Tom. And it'll say being Tom is created. Does that make sense? All right. And again, Chris kind of asked this question before. I've heard this at conferences. I've heard it, when I first learned this stuff, I said, okay, I understand what you're saying. I actually kind of understand the concepts. But why the heck do you want to do this? It just seems unbelievably complex. Because in the end, it ends up, you have a lot less code, and your code ends up being more manageable. It's kind of like the difference between, let's suppose I had 1,000 files on my computer. All right? If I put everything right on my desktop, it would be very hard to manipulate my way through those files. But if I started to make folders and I put like stuff in like folders, it would be much easier for me to manipulate my way through. It's kind of what we're doing right here. So again, I'm giving you the explanation because I don't want to sit and read their stuff. But if you're still confused, I'd recommend that you take a look at this and take a look at chapter 9 after we go over it. All right? And even then, is it totally going to make sense? No, it'll take a while. All right? Now look at where they made their way to. We're 11 pages into this 23-page document. Now we've got all of our data that's in here. All of our data is private. We have a constructor and we have a method. And our constructor must always be public, and it can never return anything. You notice it doesn't say public void, my friend. If you ever try to put a return type after, inside of a constructor, you get an error message. And that's in here, and it's in Java. All right. I don't know with any of you how good your memories are, but a year from now, you'll be learning Java. And you're going to get literally about 2 weeks Java, 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 Java. Then we're going into Android. All right? And virtually everything I'm telling you right now applies to Android. Right? And to Java and to Android. All right? So again, name of our class, private data, public methods. And one of those methods is our constructor. So that supposes that if we create a my friend object, we pass in a string that will be their name, and we pass in a string that will be born. Okay? Now, I'm going to show you this. I'm not going to even say, does it make sense? But notice, we've got born, name, name, born. See how it says this dot name equal name, this dot born equal born? If we left off that, and we said name equal name, it wouldn't do anything. What this is saying, by putting the word this there, that's saying grab that and copy it into that. And again, I'm not saying, does that make sense? You have to take a look at it before it makes any sense. So if you said, it seems like a lot of work, then you don't have to do that. We could have just called this N, and we could have just called this B. Then we could have said this dot name equals N, and this dot born equal B. In fact, if we had done it that way, we don't even need this. All right. So there's ways of simplifying what you do, is what I'm telling you.
And the name of born went from up top?
These two things that are right here, those two get passed in. They would be from wherever we created the object down here. These are these. Yeah. But again, we're using public methods to modify private data. And again, they give you a pretty big explanation of what's going on in here. All right? You may or may not remember, those of you who were in the class last semester, when we were in jQuery, we talked a little bit about chaining, where you had something dot something dot something. All right? You can do the same kind of thing in here. It says constructor chaining is the ability of a class to call another constructor. This is really confusing. All right? And if you said, do we really need to know this? I mean, I recommend reading it, but not using this right now. All right? And all it's saying is, if we wanted to, we could have one constructor call another constructor. And you say, what? Yeah, that's why I said it's confusing. You can do it. Should you do it? People who are advanced programmers oftentimes do it. I'd say if you're just starting, I would say don't even worry about that. All right? All right, I'm going to go just for a few more minutes. I want to finish this, then we'll take a break. Class constants. It says C# allows you to have class constants. You'll notice almost always your constants will be public. Think about that. Why can I make a constant public? What's one thing about a constant? It doesn't change. So if I declare something as public, that means other classes can use it, but since it's a constant, nobody can change it. Once I set it up like this, it can never be changed. All right? So I could have other classes that are using this program could use pi, and you'll notice how that one can, and there's no error. It's actually considered good programming practice to make your constants public. All right? Your data should be private. Your constants can be and really should be public. All right? This is almost the last thing that's really discussed in here, but it says every object has a toString method. You're like, toString, what the hell is that? It's actually what gets called on if you think about it, when we write a console program and you do a write line, it calls what's called a toString method to write out whatever you told it to write. All right? So as it says, toString returns a human-readable representation of an object. All right? So when you go and come in here, you create this thing right here, and notice what it says. This is a being class. The example they give is not good. All right? I'm not really nuts about the examples your author gives either. That's why probably tomorrow we're going to go in and write our own. All right? And even then, it probably won't totally make sense, but that's to be expected. All right? All right. I want to go over this part real quickly because we're going to talk about it later. This is chapter 10. This is inheritance. All right? And what it says, if you look, we've got a class called being. Then we've got a class called human that inherits from being. So when you put a colon in there like that, what's to the left of the colon is the child. What's to the right of the colon is the parent. Child on the left, parent on the right of the colon. It's the exact same way it's done in Java, except here in Java you'd say public class human extends being. So rather than using the colon, you use the word extends. So it's always this stuff. That's just a syntactical thing. So it says right here that human is automatically, human is a child of being. Why is that important? Well, look at this. We've got two write line statements in here. Being is created and human is created. You can all see those. So then we come in here and we say new human. Okay? Which means create us a new human. All right? So what prints? Being is created, human is created. What does that mean? That means that before this thing runs, it calls the constructor of the parent. That's the way things work. And again, if that doesn't make a lot of sense, that's what this chapter is about. That's the example that we'll go over. And then they give a more complex example. Now, everybody remember one thing, it always drives me nuts in console programs when you do anything that interacts with main, how you have to use that dang word static. All right. You may or may not have noticed this, but so far we've never used the word static once in here, other than where they've got, the static main, just the name of that. Okay, but look on the screen if you would. See this? Imagine that I was going to make a class called person, and then I was going to make 12 person objects, one for each one of you. And I wanted to count for how many objects I made. If I've got a variable that I want all of you to share, then I make it static. I don't make it public. I don't make it private. I make it static. Static means there's only one and you all share it. That's exactly what we'd be doing right here. So the example here is a little convoluted. It's a little hard to go through and say, oh, okay. But then they make this big thing here where they make a bunch of different classes. But the point is, if you go through that, they count and they show you how many there are. That's the key thing. So static means there's one, and it's shared by everybody. It doesn't belong to an object. It belongs to the class. Everything else we've done so far belongs to the objects. You each would have your own heights. You each would have your own weights. You each would have your own eye color and hair color. But if I made a person count, there'd be one that all 12 of you would share. All right? Finally, and again, this is something we're not going to cover till probably the end of chapter 10. But if you look in here, it says abstract classes and methods. And if you look, I was smart enough for a change to leave that example on the board. And if you look, this class, if I created a setup like this, this class would be called abstract, which means it's so generic in nature. You would, I've given you this example before. I wouldn't typically come into class and Luke says, "Why do you look so happy?" "Oh, I've just bought an animal." I wouldn't typically say that because that's kind of probably, it's too generic. And I wouldn't even probably say I bought a dog. But you'd look under here and you'd say what? Things like, a Dachshund, a Saint Bernard, etc. So I keep getting more and more specific. But if you create a class that's abstract like this, that means you're never going to create an object. I'm not going to create an animal object. It's too generic in nature. I probably wouldn't even create a dog object. But I would create a Dachshund, a Saint Bernard, etc. type of an idea. So if something is abstract, the idea is you're never going to create it. All right? If you're able to create something, it's called concrete. If you're not able to create something, it's called abstract. So I can't use the new operator to create a brand new animal because it's abstract. All right, as it says in the first sentence there, abstract classes cannot be instantiated. All right. If you put one or more abstract methods in a class, the class must be declared as being abstract. And they do show you an example in here. All right, abstract class drawing. Okay, and notice they've got in here what? An abstract method. Notice when you have an abstract method, You don't put any code in there. All right? What that means is any class that's going to inherit from drawing must make a method that's called area, and that method must return a double. That's what it says. But how I actually do that, how I figure out the area, is going to be different depending on what it is I'm working with. The area of a square would be different than the area of a triangle, etc. And that's exactly what the author is saying right there. All right? And that's it for this one. Okay? So what we're going to do is we're going to take a nice long break. It's 9. Let's come back at 9:15. And when you come back at 9:15, we're going to be going over chapter 9 from your book. All right?